Hello, my esteemed viewers. In this tutorial and in the tutorial series which will follow this tutorial, we will clearly explain the concept of arrays. So far, in the programs that we discussed thus far, we considered only one variable and we have seen them as scalars. And C is also capable of holding single data item innumerable in number, and C also supports such a kind of variables or such a kind of data which are of similar type, and it is called as the aggregates in C. There are two kinds of aggregates in C. One is arrays, the other one is structures. We always tend to group similar objects into common units. When we buy books, we put them in boxes, and if it is an apple, we put them in baskets. In computer language, we also need to put data items of similar type, huge in number, together with a common name. This grouping can be done using arrays. This grouping is done in mathematics also, and they call it as a vector. The array may be defined as a group of elements that share a common name and a common data type. And this is the classical definition of an array. Array may be defined as group of elements that share a common name and common data type. Actually, the conceptual representation of an array comes like this. There is a 5-element array. Okay, the individual components of an array is called as an element. There is a 5-element array, and these arrays will be placed in memory in contiguous memory locations, and it will carry a common name. As far as this example is concerned, the name of the array is marks, and it has 5 elements, and each and every element is represented by a mark of 0, the positional value, mark of 1, mark 2, mark 3, and mark 4. The 0, 1, 2, 3, 4 are called as subscripts or positional values. The constituents, the basic constituents of an array are called elements. The numbers used for specifying a particular element in an array is called as a subscript. Here 0 is a subscript, 1 is a subscript, and 2 is a subscript. Justifiably, an array is supposed to consist of what are called as subscripted variables. In this tutorial, we will discuss only one-dimensional array. One-dimensional array, and C permits one-dimensional array, two-dimensional array, three-dimensional array, and theoretically n-dimensional array. The dimensions comes from the fact, the way in which we access an element, the way in which we refer an element. In one-dimensional array, we can locate or access any element by locating its position in one direction. Say, in order to access the 10th element, we will have gone through all the 9 preceding elements. Some practical examples of one-dimensional array are a list of marks obtained by students in a particular subject, a list of participants for a contest, list of prime numbers, list of employees. And we need to go through the list in order to identify a particular element. And one day, like any other variable, array is to be declared. Here are 2 examples of declaration. Integer, score. This is an integer type of array. The name of the array is score, and it consists of 19 elements. And this array name is salary. It consists of all float kind of data, which are 20 in number. And the positioning starts from 0. Therefore, the 19th element will be available in the 18th place, and here also the 20th element will be found in the 19th place. And this is the other ways of declaring as well as initializing the array. Integer score 6, 1, 2, 3, 4, 5, 6. It will be taking only up to 96, and 97 will be simply omitted. Integer score, there is nothing mentioned over here. It will assume, the compiler will assume that there are 6 elements, and it is initialized. Float, rate of interest, 12.5, 13.25, and there are 1, 2, 3, 4 elements. And if array, there are 2 important points to be remembered. as far as array is concerned, array declaration is concerned, array initialization is concerned. If array elements are not supplied with specific values like this and this, they simply hold some garbage values. No, here exactly, integer score 19, nothing is filled over here. Therefore, all the 19 elements in their memory location, respective memory locations, will contain some garbage values here also. And here in the second example and the third example over here, the array size need not be written separately. It is optional, as in the second and third examples above. Right. Entering data into an array. This is the way, that is scanning the elements into an array. First of all, it is to be declared. This is a program snippet, of course, in order to reinforce our understanding as far as entering data into an array and printing the data, or displaying the data availed from an array. Okay, integer array 10 j. There are 10 elements, so therefore we need a for loop. Exactly in the looping constructs, I have told to my respected viewers that arrays and iterative constructs will always go together. And here it is. For j equal to 0, j less than 10, j plus plus. This exactly takes 10 elements, because 0, it starts from 0. Enter the elements of an array. So here %d ampersand array of j. So array of 0, array of 1, array of 2, like this it goes. Printing the elements of an array. And this is the way we can print the element of an array. And here j equal to 0, j less than 10, j plus plus. Okay, and the elements will be printed, and here ampersand is missing. Okay, because it prints only the value. Here it will go to the addresses of subscripted variables. The values will go to the addresses of subscripted variables. Okay, an array consisting of 10 elements is supposed to have 10 subscripted elements, subscripted variables, starting from array of 0 to array of 9. And here this is the another way of printing the elements of an array. For j equal to 0, j less than 10, j plus plus, printf %5d array of j. And here there is a space of 5 spaces are there. 5 spaces are there here. Okay, the elements are filled. So, okay, 1, okay, 2, 3, 4, 5. Let us say if the first element is 85, it is going to be filled up like this. And second element, once again there will be 5 spaces. It will be enter, or it will be written in a right justification. Okay, next. It is not really good to simply input the array and output the array. We need to do some of the standard manipulations over an array. When an array is manipulated, then some important or significant information can be driven out of this arrays whenever they are manipulated, because array contains substantial amount of data of similar type. Okay, with a common name in the memory, with a common name given to the memory location. Okay, these are all the standard manipulations that will be used in technical programs. And by the by, our viewers should understand that there is no single program on earth minus arrays. Okay, and here it is initialization and duplication is the first kind of primitive task, primitive manipulation that could be done. Accumulation of elements into a common variable, and reversing of an array, and arithmetic operations or algebraic operations on an array, sorting an array elements, and searching in an array, merging two arrays. These are all the standard manipulations of an array. Each and every manipulation will drive out some significant information to the users of the array. Of course, and arrays are also used heavily in statistics. Okay, in statistics related manipulations or computations. The following program sets all 10 elements of an array by name 0 to zeros. Array a variable to value of a variable x. Count an array count to numbers from 0 to 9, and creates a copy of values holding 10 integer values in duplicate array. So here the names of arrays are given in such a way that it will give a notion of what exactly it contains. 0 is the name of an array which contains 10 zeros. A variable is a name of an array which contains a variable value. Count is an array name which contains numbers from 0 to 9, and values is an array. Values is an array consisting of 10 integer values, maybe different integer values, and these values will be duplicated in another array called as duplication. So by doing this particular program, we will clearly understand as to what do we mean by initialization of an array and duplication of an array, the very first manipulation. So include stdio.h, include conio.h, all these things are there as usual. Integer I to run the loop, 0, name of the first array. Okay, it is initialized with 10 elements. Our a variable, 10 elements, count, values, dupli, and x. X is to be used in order to fill up this particular array. All 10 elements of this array will consist of a value of a variable x. And here it consists of 10 values which may be different. Of course, they are integer values because these arrays are integer arrays. Okay, type of array is decided by the type of value it holds. If it holds integer kind of a value, it becomes an integer array. If it holds float kind of value, it becomes a float array. Right, read a variable x, enter the value for x. Okay, user will be given this particular suggestion and user will enter a particular integer value. Now, for I equal to 0, I less than or equal to 9, because we need to do for 10 elements I less than or equal to 9. It should go up to 9, or we could have written I less than 10, I plus plus. Okay, this is the for loop. Print of enter a value %d. So here I will be printed. Enter a value for value array 0, value of 0, value of 1, value of 2 as this iteration goes by. Prompt to enter the elements. Scanf %d values I. So here user will enter. Let us say he enters 10. It will go over here. 0 of I. This is the array called 0. 0 of 0 will be equal to 0. 0, 1 equal to 0. 0 of 2 equal to 0. So all the 10 elements in 0 array will be filled with zeros. A variable I, x, and this x variable is already read over here, and this particular x variable will be filled into this particular array. A variable equal to count I equal to I. So here this count array will consist of elements. Count of 0 equal to 0 because I brings in 0. Count of 1 equal to 1. I becomes 1 in the second cycle. I become 2. Therefore this count array will consist of numbers from 0 to 9. Okay, all the 10 elements will have 0 to 9. Dupli of I. This is an empty array, and this will just copy whatever that is there in an array called values array. Now this is called as initialization, and you should remember a very important point. The initialization of an array usually happens without the use of keyboards. Here we are just filling it, and for loop does the magic. And here duplication, this is the duplication manipulation that is being done an array. So this is the printing of an array. For I equal to 0, all the 5 arrays, for I equal to 0, I less than 10. We have used a different condition over here. Here it is less than or equal to 9. Here it is less than 10. Therefore it is one and the same. I plus plus. %3d, we have given for each and every element of these 5 arrays 1, 2, 3, 4, 5 arrays a space of 3, so that we will feel that they are separated. By an extent of this particular width. 0 I, so 0, 1, 0, 0, 0 of 0 will be printed, and a variable of 0 will be printed. Count of 0 will be printed over here. Values of 0 will be printed over here, and dupli of 0 will be printed over here. When it goes for the second cycle, I will become 1, and all the first elements, say the elements found in the number 1 position, that is index 1 position, will be printed over here. Anyway, we will get a neat table of these arrays printed one after the other in a columnar way. Of course, we could have generated some kind of a title for this also by the title of the arrays. In order to create a title, as I said in one of the tutorials, the title should always should always be written before the for loop. Okay, here we could have written a title, okay, designating the name of each and every array. Upon running, enter the value of x equal to 12. So enter values of 0. So these are all the different values that goes to a array called values. So 10, 11, 12, 13, 14. This is what user has entered, and this is how the printing takes place. So this is 0 array consisting of 10 elements. This is a variable array consisting of a variable value that is equal to 12, and this consists of this is a array named count, which will have 0 to 9, and this will have different number of values, 10 in number, okay, taken into an array called value, and it is duplicated in dupli. This is dupli array. Okay, there are 5 arrays: 0, a variable, count, values, and dupli. Now example 2. Here in this program accumulates the product of all the elements of an array into a single variable. This is actually called accumulation, the process of accumulation. It is accumulating number of data items of similar type into a lone variable. Okay, these data being drawn from an array. Okay, so integer a, this is initialized and declared. Declaration and initialization happens in one go. Of course, this kind of declaration and initialization could be done only if number of elements are limited. Okay, integer p equal to 1, because this p is meant for generating the product equal to 1, it is initialized with 1. I, a loop index. So for I equal to 0, I less than 5, I plus plus. So because there are only 5 elements, the for loop also runs for 5 elements. P equal to p into a of I. So p into a of I. 1 into 2, 2 into 3, 2 into 3 into 4, like this it goes on, and the value will be accumulated and it will be printed over here. Okay, the product of all the elements of an array is p. The product of all the elements of an array in this case happens to be 840. Right. Example 3 is all about a different kind of accumulation. We have 2 arrays, namely a and b, and a of 0, b of 0, a of 1 and b of 1 will be successively added into a discrete value or into a scalar, and it will be stored in sum. This is also accumulation of 2 arrays into a lone variable called sum. Okay, this kind of situations would arise in statistics. Therefore, these kind of manipulations are very much significant whenever we think of some primitive tasks in statistics are concerned. Okay, when I will revisit this kind of examples when we take up the programs of statistical nature. Okay, integer sum equal to 0. This one initialized with, because this is an accumulator. I to run the for loop, a of I, b of I, 2 arrays. I enter the elements of an array a and then b. Okay, print a of percentage d, a of I percentage di, so a of 0. So this will be printed as a of 0, and cursor will be blinking over here. So the user will enter a first value. The first value will go to a, and so scanf is done over here immediately. Printf b of percentage d of I. So here b of 0. So it goes cyclically like this. In the first iteration, a of 0 will be filled up, b of 0 will be filled up. In the second iteration, a of 1 will be filled up and b of 1 will be filled up. Okay, like this 10 values will be entering into a array first and b array next. And then in order to get the sum, we once again go for the for loop and we will just sum it up. Sum equal to sum, the earlier value of the sum, that is equal to 0, which was initialized to 0. It was initialized to 0 somewhere over here. Yeah, and then sum equal to sum plus a of I plus b of I. So sum of all the elements of arrays a and b equal to percentage d, and it is sum. Okay, this is the value, this is how it is entered. For the sake of clarity, all the values are entered to be 10. You can note is 0 0 1 1 a b like this. Finally it ends up with b4. Okay, and the fifth element is in the b fourth index, and the fifth element of a is in also in the fourth index, and the total value is equal to 100. And we will answer one important question. Okay, when exactly a programmer should feel that he or she should use an array. We can consider an example over here. I will quickly do. Let us say we have a situation of finding average marks of 1000 students, let us say, for some kind of a university statistics, related statistics. I equal to 0, a simple for loop will do. If at all you want to calculate only the average marks obtained by 1000 students of a particular university in a subject like programming in C. Okay, it is less than or equal to less than 1000, yeah, and I plus plus, yeah, this done. Now sum is initialized to 0. So sum will become, so we will scan the marks of the first student. Okay, we will scan the marks of the first student, percentage d, marks being an integer, it will be declared as an integer variable, ampersand of marks I, yeah. First the marks of the first student will go, and sum will be accumulating the first marks. So sum equal to the earlier value of sum, that is 0 plus marks of I, like this. In the second cycle, the second student's marks will go and get added up with sum, with sum. And after the completion of this for loop, what we get is sum of the marks of all the students. What happens here is, whenever the marks of the first student is entered, it will be taken and it will be added over here. Whenever the second marks of the second student is entered, and the marks that has already been entered for the first student will be overwritten. It will be overwritten, ampersand of marks. Okay, and let me not use this arrays. Okay, this is in the absence of arrays I am explaining. Sorry. This is not an array. Okay, marks. So first marks of the first student will go and it will get added. Whenever we try for the second student marks, the first student marks which was stored in marks variable will be, it is not the question of deletion, it will get overwritten. Like this, so what remains in the memory is the marks of the 1000th student, the student number 1000. The 1000th student marks will only be available. Now we can find the average here. It's a very simple task now. It is just like this. So average equal to average marks, or university average marks, equal to sum divided by 1000. Sum divided by 1000. So it is pretty easy if we do only this kind of task. Of course, arrays are not at all needed. A simple for loop will do. Now, if you want to answer questions further like this, let us say, how many students are below average and above average? Because we have lost all the 999 students' marks, it is impossible. We have only the average value and the last student's marks. Therefore, we will be at a loss in order to answer this particular question. Once again, we need to enter all the 1000 marks. There will be drudgery of inputting the data. How many students are above 90%? So here the process is repeated, and here also the process is repeated. Here the comparison of each and every marks obtained by student will be compared with the average, and here all the students' marks will be compared with the average, which is at 90%. Therefore, a simple answer that can be given to this particular excellent question, that is significant question, when exactly we should think of using an array, the emphatic answer is whenever we need to process huge data of similar type repeatedly in a program, arrays are a must. Whenever we need to process huge data of similar type, like integers, like marks, 1000 marks, it should be repeatedly used. Once to calculate the average, second time to compare, to find how many students are above average or below average. The next time, how many people are above 90%. So 3 times of processing has been done on the same data. Therefore, this is the situation when a programmer finds arrays to be very handy. And it is very important to note that arrays will provide some kind of a permanence for the data. I repeat, arrays will provide some kind of a permanence for the data. Of course, we can store these arrays in a file and we can use whenever we want. So with this, we discussed only preliminary aspects of an array at a very primitive level, and the following tutorials will explore this array into significant processing and significant manipulations and significant computations. Okay, with this we will close this session.